Imagine this. Albert Einstein once said that no matter how powerful our telescopes become, humanity would never witness the true beginning of the universe. And yet, against all odds, the James Webb Space Telescope has now captured something so extraordinary, it could be the closest we've ever come to seeing the very birth of everything. But what it revealed was not galaxies, not stars, not even light. Instead, Webb found a vast emptiness, an endless void stretching across the dawn of time itself. Could this chilling darkness actually be the universe in its first moments? The very inception of reality? This discovery is not just a milestone, it could hold the answers to some of the deepest mysteries of our existence. You see, the beginning of the universe was unlike anything we can truly imagine. The event we called the Big Bang didn't blaze with light. It unfolded in complete, unfathomable darkness, on a scale that defies our physical comprehension. According to modern cosmology, our universe burst forth 13.8 billion years ago from an almost impossibly small singularity, perfectly balanced until the tiniest irregularity tipped it into expansion. From that singular point, everything we now know was born, and echoes of that primordial state still survive today, hidden within black holes, where gravity bends reality to the very edge of infinity. Now Webb has peered further back than ever before, catching a glimpse of a black hole and an immense void from a time before the first stars ignited. Picture it, the newborn cosmos, a searing ocean of particles and radiation expanding faster than comprehension itself. At this stage, photons, the very particles of light, were trapped, endlessly colliding with protons and electrons, unable to break free. The universe was opaque, smothered in darkness. It took nearly 380,000 years before things began to change. The chaos cooled, atoms formed, mostly hydrogen and helium, and finally, photons escaped, creating the cosmic microwave background, the faint afterglow of the Big Bang we still detect today. But even then, the universe remained black. There were no stars, no galaxies, just silence. It wasn't until hundreds of millions of years later that the first stars finally ignited. Gravity pulled vast clouds of hydrogen together, compressing them until nuclear fusion lit up their cores. These colossal beacons unleashed blinding ultraviolet light, reionizing the cosmos and tearing apart hydrogen atoms, making the universe transparent at last. And in that moment, the first cosmic dawn began. The light from those very first stars pierced through the cosmic fog, ripping apart the veil of neutral hydrogen that had cloaked the universe in darkness. Slowly, step by step, the cosmos became transparent. This grand transformation, known as reionization, signaled the end of the Dark Ages and the true beginning of the universe as we know it. But here's the limit of our vision. No matter how advanced our telescopes may be, we can only peer back to the moment when light finally broke free. For decades, scientists believed that this threshold, the earliest point we could observe, was locked at about 380,000 years after the Big Bang. That was the story, until now. The James Webb Space Telescope, humanity's most powerful window into the cosmos, has begun to rewrite the script. With its array of 16 golden honeycomb mirrors and unmatched infrared sensitivity, Webb captures light that has traveled across 13.5 billion years of cosmic history. It has already uncovered galaxies so ancient they defy our expectations. But its most shocking revelation yet? A black hole lurking just 500 million years after the Big Bang. This discovery shakes the very pillars of cosmology. The black hole is not only ancient, it's colossal, weighing an astonishing 10 million times more than our sun. And yet a black hole is paradoxical by nature, an abyss of emptiness swallowing all around it while bending reality itself with its immense gravity. How can a void carry such weight? Scientists suggest black holes gorge themselves on matter, growing fat on gas, stars, even entire solar systems. Others point to the hidden hand of dark matter, an invisible substance we cannot see, but whose gravitational fingerprints warp galaxies and space-time alike. But what makes this discovery so unsettling is not its size, it's its speed. Webb's observations reveal that this black hole is growing at an astonishing rate, far faster than modern physics can explain. If we trace its growth backward, the numbers break reality itself. According to our current models, this monster should be older than the universe. Impossible? Or so we thought. Some theories whisper of a precursor universe, a cosmos before our own, leaving behind remnants like seeds that could bloom into massive black holes after the Big Bang. Others suggest that black holes in the primordial universe were born different, governed by laws of physics we have yet to grasp. What is certain is this: Webb's discoveries are dismantling old theories and forcing us to confront new ones. Galaxies that seem to exist before they should, black holes that grow too fast, too massive, too soon. Each image Webb sends back does more than reveal. It challenges, disrupts, and dares us to rethink everything we thought we knew about the origins of the cosmos. New theories are now rising, while old ones are being dragged back into the spotlight. One bold idea is the theory of variable physical constants. Imagine a universe where the fundamental rules themselves, gravity, electromagnetism, even the strength of atomic forces, were different at the dawn of time. If constants like the gravitational constant or the fine structure constant had alternate values, they could explain why galaxies grew so rapidly and why black holes in the early cosmos ballooned far faster than they should have. But there's another contender, even stranger: quantum gravity. This elusive theory attempts to bridge two titans of physics: Einstein's relativity, which governs the vast cosmic stage, and quantum mechanics, which rules the microscopic world. Normally, these two frameworks cannot coexist, but in the earliest instance of the universe, when everything was compressed into something unimaginably tiny and dense, quantum gravity may have reigned supreme.
And here's the catch. The Big Bang model, the very foundation of modern cosmology, was built primarily on Einstein's large-scale physics. If quantum laws actually dominated the earliest moments, then our equations, our timelines, even our predictions could all be flawed. And James Webb's discoveries are now exposing those cracks. To understand how we got here, we need to go back a century. The idea of the expanding universe first emerged in the 1920s, when Belgian astronomer and priest Georges Lemaitre proposed that everything we see today burst forth from a single compressed point, what he called the primordial atom. Around the same time, Edwin Hubble measured the recession of galaxies, revealing that the universe was indeed expanding. From these revelations, the Big Bang theory was born. For decades, additional theories were woven in, building the grand tapestry of our cosmological worldview. But now Webb is showing us pieces that don't fit. Galaxies appearing too early, black holes too big, too fast, patterns that refuse to match the story we've been telling. The mystery of the first black holes is at the heart of this debate. How did they appear so soon? One possibility is that they were born from the deaths of massive population 3 stars, the first generation of stars, titans made almost entirely of hydrogen, burning hot and dying young. Their violent supernovae could have left behind black holes as cosmic relics. But another, even more radical theory suggests something stranger still, that black holes may have formed before the very first stars lit up the cosmos. In certain conditions, vast rotating disks of gas and dust, normally destined to form stars, could instead collapse directly into black holes. If true, this means black holes may have existed even before the very first stars lit up the cosmos. We also know that the early universe hosted supermassive black holes, with masses ranging from millions to billions of suns. How they reached such enormous sizes in such a short span of time remains one of astronomy's biggest mysteries. One idea is that smaller black holes merged together, feeding on surrounding matter and combining with one another. But this explanation requires stars and stellar material to exist first, raising new questions. This is where the James Webb Space Telescope changes everything. With its unmatched ability to peer deeper into time than any previous observatory, Webb can reveal the earliest galaxies and quasars powered by these colossal black holes. Acting as a cosmic time machine, it captures ancient light billions of years old, allowing us to look directly into the infancy of the universe. Each discovery from Webb has brought new surprises, challenging astronomers with phenomena that defy our models. And at the heart of this mystery lies one of the greatest puzzles of all: the birth of the first black holes, a riddle written into the fabric of space and time, waiting to be solved.